Hey everyone, this is the 2018 exam. This is number 4. This is the no calculator section, and this is part B. So number 4 said the height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. So h of t is the height in meters, and then we have time in years. Part B asks you to explain why there must be at least one time t between 2 and 10 such that h prime of t is equal to 2. So this is going to be a theorem question. Take a second and think if you can figure out which theorem is going to be used. So because the chart gives you h of t, if the question were, does the height ever have to equal 13? If this was the question, that would be an IVT question. And you would say, yes, the height is going to hit 13 here, in between those numbers, etc. That's an IVT question. Because this has a prime, h prime of t, that is an MVT question. So the MVT, see if you can remember what the MVT says. It is that the instantaneous rate of change equals the average rate of change. And what do these things mean? Instantaneous rate of change. So rate of change is slope. Instantaneous means you're using 1 point. For average rate of change, again, rate of change means slope. Average means you're using 2 points. The instantaneous rate of change, which is the slope at 1 point, is the same thing as the what? It's the same thing as the derivative. So instantaneous rate of change, the slope at 1 point is the same as the derivative. And then they want to know, is that ever going to be equal to 2? Meaning 2 is the average rate of change. So again, the MVT says the instantaneous rate of change, that's this, is going to equal the average rate of change, which is this. So they're saying that 2, or they're wondering if 2 is ever going to be the average rate of change, because we have the instantaneous rate of change on the left side. So we would have to look at the chart. I think this part is one of the most difficult parts, just to find where it's happening. So you're looking for, where do you have an average rate of change, a slope between 2 points of 2? So I'm going to give you one that does not work. This one would be wrong, because when you find the slope, 15 minus 11 and 10 over 10 minus 7, that gives you 4 over 3. So that does not give you an average rate of change of 2. But take a minute and see if you can find where the average rate of change is 2. That is going to happen here. So the first thing you would write down is that slope. If you are using fancy function notation, you can write it like this. That's not required though. Even if you just write 6 minus 2 over 5 minus 3, and you get 4 over 2, which is 2. Sorry for my spacing there. Even just writing that second part is fine. So the function notation is not required, but there it is, if that makes sense to you. So you are showing that, yes, the average rate of change is 2 at some point, and then you just need 2 more parts. So then we're going to use the MVT. In order to use the MVT, think about the 2 conditions that have to be met. They tell you that h is differentiable. So you would write h is differentiable, which means it has to be continuous. So we would always write h is differentiable and therefore continuous. And writing that sentence is what allows you to use the MVT and apply the MVT. And why are we applying the MVT? Because if you have differentiability and continuity, then the MVT says, then you are guaranteed to have an instantaneous rate of change equal the average rate of change. So I'm forgetting differentiable and therefore continuous. I'm going to write, I always forget this part, on the given interval. And then you're going to say that you're using the MVT. The MVT guarantees, and then I'm going to just zoom out because I'm going to copy from the question here. The MVT guarantees, and this is all copied from the question now, there must be at least one time t for 2 to 10 such that h prime of t equals 2. Okay, and then I'm just going to highlight all of that was copied from the question. So we know that that's a great thing to do. So you showed the average rate of change of 2. You set up why you're allowed to use the MVT because of the differentiability and continuity. And then you actually have to say MVT to show that you're using that theorem. And then the rest of that sentence is copied from the question. So that was the MVT proof. This is a 2-point question. So the first point is if you can just show a slope of 2. And so you've got that fancy function notation, but even if you can just write that one, that's great. And then the second point is the conclusion using the MVT. So you see h is differentiable and therefore continuous by the MVT. There is a value, etc. I'm just looking at how they use 3 and 5, and I used, what did I use? Oh, I just wrote on the given interval. Okay, got it. All right, that's it. Great job.